Hello guys, welcome back to my channel. As promised in my previous video, we will learn about what is ROC curve. Okay, so let's get started with some of the theoretical part, and then we will deep dive into theory and the practical session, and we'll see how we can actually implement a ROC curve. Okay, so whenever we build any models, okay, so what we do, we need to measure the performance of the model by using different parameters and different metrics, we can say. Okay, so ROC curve is one of the metrics. It's a graph which shows the ratio between the true positive rate and the false positive rate of a model. Okay, now what is true positive rate and what is false positive rate, I am going to explain. Okay, so what is the full form of ROC? So ROC stands for receiver operating characteristics. So it's taken from some electronical or engineering background. So this word came from there. Okay. So it is a graphical representation of a binary classification of a model performance. Okay. So how your model is performing, we are seeing it in a graph. Okay. So let me open my Excel and let me walk you through an example. So what I have did, I have printed this data frame, this whole data frame to a Excel. Okay. So let me open that Excel. Okay. If you see, these are the three columns which I have printed from our model. Okay. And where all these columns came from, we will see. Okay. So we have printed all these from our model. Okay. Now let's go ahead. What I am doing, first of all, I am setting a cutoff. So what is a cutoff means, basically any value in this churn probability. So if probability is greater than this value, we will say it as 1, or else we will say it as 0. Okay. So suppose where I put it 1 0 here. Okay. Now you will see the value will change here. Let me go down. So values in this row will change according to this cutoff rate, and these values will also change. How it's working, let me explain you. So till now you understood that what cutoff is. So cutoff is basically we are setting a value uh, to make everything 1. If this value is greater than the cutoff value, we'll say 1, else we will say it is at 0. Now we will learn about two we can say terminologies which we are going to explain. So first one is the positives. So positive is basically all the ones in this column, means all the cases where the model has predicted as 1 or true. So how we can get that? We will simply sum up this column and we will get this value. So all the ones, the count of all the 1 is 1287. Okay. Negative where all the negatives is 0. Okay, where all the values are 0, we will say that we'll say it as negatives. And churn rate is positive divided by positive plus negative. Okay, so these are the three columns. Now why we have calculated these? We have calculated these because we need these to calculate our TPR and FPR. So let's understand first of all what is TPR and what is FPR. Okay, so TPR stands for true positive rate. Okay, so it means number of customer which are going to churn, and our model has also says that they are going to churn. Okay, means total number of correct prediction of our model. Total correct prediction done by our model is true positive. Okay, so how to calculate true positive rate? Basically all the cases where our model is correct, divided by the total positives. And how do we get that our model is correct or not? So basically we are checking if both these value is 1, we are counting them where both of these are 1. Okay, so that is true positive, and we are dividing it with the positives to find the true positive rate. What is false positive rate? Just a vice versa. Okay, where the person is already the person is non-churn, but our model as says it as 1. Means a person is like a person is not going to churn, and our model is saying that he or she is going to churn. That all cases will known as false positive rate. Okay, false positive means the cases where it's not actually positive, but our model is saying that it's positive. So if we change this cutoff value, of course our values in the TPR and FER will change, because it's dependent on the prediction of the model. Correct. So if we say 8 here, every value sorry, most of the values here, or if you make it here 9, you can see all the values became 0. Why? Because the range is, the highest range is 0.86, and we have said 9 here. So it will compare whether it's greater than this value. No, so it will make it 0. So if we put if we make our cutoffs too high, everything will be treated as false. And if vice versa, if we make our cutoff too low, everything will be treated as 1. Okay, so we have to keep our cutoff in such a way that both of these value TPR and FPR should be balanced. Okay, how to find a cutoff rate, we will say, we are going to see in our next video. Okay, so what I have did till now, I have created a table by setting different cutoff value and recording the FPR and the TPR, and I have created a scattered chart using these values, these two values basically, and this is only which is known as ROC curve. Okay, so a good ROC curve should look something look like your all the values should be hugging around this one. Okay, and a bad ROC curve will be vice versa. It will go like this or this. Okay, so basically this area we want to achieve in a ROC curve. Okay, around 1 we want all the like hugging this area. So we can see our model prediction is hugging this area, so we are good, our model accuracy is good. Now let's go ahead and do the same thing in Python. Okay, let me go ahead and do the same thing for Python. Okay, so let's go ahead and take a cell here. Let me, I have already written the code just to save our time, and I will explain this code. So what the code is basically saying, we will see. So as you can see, this function is taking two values. First one is the actual values which we are getting from the training data set. These are the actual values, and these are the probability which our model is predicting. Okay, so we have taken these two values, and we are calling scikit-learn's ROC curve function to create a ROC curve. And we have made the drop immediate as false. Why? Because we want to include all the possible threshold, even those that don't appear in the probes array. So we have kept it at drop immediate equal to false. Then we are creating the ROC curve and the ROC AUC score. What this function is doing, this is basically computing the area under your curve. So which area under it falls in your curve, this this function is doing that. Then we are initializing our graph, we are setting the limits, okay, using the xlim and ylims, we are setting the label and the title, and done. Okay, so now we are good with this. Now let, so if you see, graph has been drawn, and this is same as the Excel graph. If you remember, these two are basically looks like a same graph. Okay, so we are good with this model because we are getting the values closer to this area, this basically this area. So in next video we will learn about Navibias classifier, uh, what is it, the introduction, and how we can implement it. So till then, bye bye, take care.